So let's say you are asked to square a number, for example 73 squared. What would you do? Well, most people will just use a regular multiplication method to find the solution. However, this is definitely not the best method to square a number. There is a much faster method designed specifically for squaring numbers, and today that is what I'm going to show you. So first, I'm just going to explain how to use this method. I'm just going to use the example of 73 squared. So the first step for this method is to square both of the digits, so that would be 7 squared and 3 squared, which is just 49 and 9 respectively. However, we need to make sure that each of these numbers are 2 digits, so we just make the 9 into a 0, 9. Now we just combine these two numbers together into 4909. Now for the next part, we multiply 3 and 7 together, so the two digits together, to get 21, and then we double it to get 42, and then we place it one digit from the right, so right there from the first number, and then we just simply add them together to get our answer, 5329. Very simple. And here is just another example with 89 squared. Now you might be wondering, how does this method work? Well, it's based on the algebraic expansion of the two-digit number 10a plus b squared. This is just 100a squared plus 20ab plus b squared. Now the 100a squared plus b squared is going to be the first part of our method. It is where we square the numbers and then we connect them together. The second part is the 20ab, and when we multiply the numbers together and then we double it, and we have to place it one digit from the right so that it's multiplied by 20, not 2. So this method can actually also be applied to numbers with more than 2 digits. Just as an example, to demonstrate these actually two different methods to use for more than 2 digits, I'm just going to be using the example 3-digit number 732 squared. It doesn't matter how many digits you have and what number it is, I'm just going to be using this as an example. So now for the first method, we're just going to first start with the numbers, so 732. Now we're going to split this number into two parts, so the first part consisting of the first few digits and the second part consisting of the last digit, so 73 and 2. Now we actually simply just treat this as a two-digit number, where the first few digits, so the first group is the first digit, and then the second group is the second digit. So we just basically apply the same method. So we first square each of the numbers and put them together, so that'll be 5329 for 73 squared, and then 2 squared is 04, so then we add that at the back. And then again we multiply these two together and then double it to get 292, place it one digit from the right, and then we add them together to get 535824. So that's the first method. Now the second method is more of an extension of the first method. So first, again, we start with this number 732, and now we're going to square each of the individual digits and then just string them together. So 490904. Now instead of multiplying all of the digits together, we're going to multiply each of the digits 2 at a time. So we multiply 7 by 3, 7 by 2, and 3 by 2, and then multiply each of those numbers by 2, and then place them some amount from the end. This amount is actually a little bit hard to calculate. I would explain how they work for more than 3 digits later, but for 3 digits it's just the first two numbers multiplied together, 3 from the right, the first and the last 2 from the right, and the last 2, 1 from the right. And then we add these together to get our answer. So now I'm just going to explain the second method, the multiplying of the pairs of digits more in detail. So the second method, just like our basic squaring the number method for 2-digit numbers, it is based on the expansion of 100a plus 10b plus c squared. So 10,000a squared plus 100b squared plus c squared plus 2000ab plus 200ac plus 20bc. So again, the first three is just stringing together all the squares of the individual digits. Then the multiplication of the different pairs of digits is in the second part. So the number of zeros at the end of each of them. So for example, AB would mean the first two digits. That means there are 3 zeros for 2000. So that means you will need to press in 3 digits from the right. So then AC will be 2 digits, and BC will be 1 digit. And so you just have to use this to calculate the number of digits from the end for 4 digits and beyond. Now with these two methods, you might be wondering, which one should I use? Well, just like a lot of things, it depends. So if you are trying to do this calculation in your head, so not like on a sheet of paper or something, then I would recommend using the first method because it requires working with less numbers at once. However, if you are working on paper, then I would recommend using the second method because it requires less complicated calculations. So that's it for this video. Thank you for watching. Hope you found this video interesting and helpful. I actually use this method myself almost all the time, so yes, you can confirm that it is definitely a very good method. You can just try it yourself, and this can also help you, as I suggested before, you can help you do it in your head, so that can also be very useful. If you have any questions, then you can leave them in the comments section below, and otherwise I think I'll see you in the next video.